Binomial expansion when n is rational or fraction number. For n is a positive integer, 1 plus x to the power of n is equal to 1 plus nx plus n minus 1 over 2 factorial x to the power of 2 plus until plus x to the power of n. For n is rational number, 1 plus b to the power of n is equals to 1 plus nb plus n minus 1 over 2 factorial b to the power of 2 plus n minus 1 n minus 2 over 3 factorial b to the power of 3 plus until plus b to the power of n. And for validation, modulus b less than 1. Example 1. Find the first 4 terms in the expansion of the following functions in ascending power of x and state the value of x for which the expansions are valid. A. 1 plus x to the power of 1 over 4. B. 1 minus x over 2 to the power of 1 over 3. 1 plus x to the power of 1 over 4 by comparing with 1 plus b to the power of n, b is equals to x and n is equals to 1 over 4. Since n is rational number, substitute into binomial formula for n is rational number. Simplify. The first 4 terms are 1 plus 1 over 4x minus 3 over 32x to the power of 2 plus 7 over 128x to the power of 3 plus ... The expansion is valid for modulus b less than 1. Since b is equals to x, so modulus x less than 1, to open the absolute value symbol, so the answer is negative 1 less than x less than 1. 1 minus x over 2 to the power of 1 over 3. By comparing with 1 plus b to the power of n, b is equals to negative x over 2, n is equals to 1 over 3. Since n is a rational number, substitute into binomial formula for n is rational number. Simplify. The first 4 terms are 1 minus 1 over 6x minus 1 over 36x to the power of 2 minus 5 over 648x to the power of 3 plus ... The expansion is valid for modulus b less than 1. Modulus negative x over 2 less than 1. To open the modulus symbol, so the answer is negative 2 less than x less than 2. To expand a plus b to the power of n, where n is rational number, it must be converted to standard form. A plus b to the power of n. First, you have to factorize for a, so become in bracket a in bracket 1 plus b over a to the power of n equals to a to the power of n in bracket 1 plus b over a to the power of n. The expansion valid if modulus b over a less than 1. Example 2. Find the first 4 terms in the expansion of the 8 minus x to the power of 1 over 3 in ascending power of x and state the value of x for which the expansions are valid. 8 minus x to the power of 1 over 3. First, convert to standard form. Factorize for 8. So become 8 to the power of 1 over 3 in bracket 1 minus s over 8 to the power of 1 over 3. 8 to the power of 1 over 3 is equals to 2. 1 minus x over 8 to the power of 1 over 3. Since n is 1 over 3, so we use the binomial expansion for n is rational number. Substitute into formula. Simplify. So the first four terms are 2 minus 1 over 12x plus 1 over 288x to the power of 2 minus 5 over 20,736 x to the power of 3 plus dot dot dot. For expansion to be valid, modulus b over a less than 1. Modulus negative x over 8 less than 1. To open the modulus symbol, so become negative 8 less than x less than 8. Example 3. Expand 1 plus 3x to the power of 1 over 3 in ascending powers of x up to the term in x to the power of 3. State the value of x which the expansion is valid. Hence, evaluate third root of 8.24 correct to 5 decimal places. 1 plus 3x to the power of 1 over 3. Okay, so we compare with 1 plus b to the power of n. b is equal to 3x and n is equal to 1 over 3. Since n is a rational number, so we use binomial expansion for n is rational number. Substitute, simplify. So the answer is 1 plus x minus x power 2 plus 5 over 3 x to the power of 3 plus dot dot dot. The expansion valid if modulus b less than 1. Now b is 3x. So modulus 3x less than 1. To open the modulus symbol, so the answer is negative 1 over 3 less than x less than 1 over 3. To evaluate third root of 8.24 is equals to 8 plus 0.24 to the power of 1 over 3. We compare with 1 plus 3x to the power of 1 over 3. Factorize for 8. So 8 to the power of 1 over 3 is equals to 2. 1 plus 0.03 to the power of 1 over 3, we compare with 1 plus 3x to the power of 1 over 3. By comparing, so s is equals to 0.01. So next, substitute x equals to 0.01 into binomial expansion, simplify, and the answer is 2.01980 correct to 5 decimal places. Example 4. Expand 1 minus 2x to the power of 1 over 2 in ascending powers of x up to the term in x to the power of 3. By letting s equals to 1 over 100 in this series, evaluate set to correct to 5 decimal places. 1 minus 2x to the power of 1 over 2. We compare with 1 plus b to the power of n. b is equals to negative 2x and n is equals to 1 over 2. Since n is a rational number, substitute into binomial expansion for n is a rational number, so the answer is 1 minus x minus 1 over 2 x to the power of 2 minus 1 over 2 x to the power of 3 up to the term in x to the power of 3. The expansion valid for negative half less than x less than 1 over 2. From left-hand side, substitute x equals to 1 over 100. Simplify. 98 over 100 to the power of 1 over 2. 98 is equivalent to 49 times 2. Simplify. So we get 7 sec 2 over 10. From right-hand side, we substitute x equals to 0.01 into expansion. So the answer is 0.9899495. By comparing left-hand side and right-hand side, sec 2 is equals to 1.41421 correct to 5 decimal places. Example 5. Expand 1 plus 3x to the power of 1 over 3 in ascending powers of x up to the term in x to the power of 3. By letting x equals 1 over 125 in this series, evaluate third root of 2 correct to 5 decimal places. 1 plus 3x to the power of 1 over 3. We compare with 1 plus b to the power of n. So b is equals to 3x and n is equals to 1 over 3. Since n is rational number, substitute into binomial expansion for n is rational number. So the answer is 1 plus x minus x to the power of 2 plus 5 over 3 x to the power of 3 up to the term in x to the power of 3. These expansions valid between negative 1 over 3 to 1 over 3. From left-hand side, substitute x equals to 1 over 1 to 5. Simplify. 1 to 8 is equivalent to 64 times 2. So we get 4 times third root of 2 over 5. From right-hand side, substitute x equals to 1 over 1 to 5 into expansion. So the answer is 1.007936512. We compare from left-hand side and right-hand side. Third root of 2 is equals to 1.25992 correct to 5 decimal places.